Hey guys, thank you for showing up to my Twitch. Um, I was a bit late. For some reason, I was having an issue with my OBS, but we are live now. So, what have I done this past week? Well, if you follow me on Twitter, you know that I was reading a ton the past weekend. I was basically trying to figure out how to implement a feature, which we are going to work on today. Um, and after that, after a bunch of reading, I did do some coding throughout the week, and I wish I would have streamed all of that, but uh, it didn't occur to me that from now on, I should stream the whole development of the game engine. So basically, that's what I want to do moving forward. Uh, Doing like just do a live stream of the game engine as a whole. Let's see how that works out. All right, let me give you some updates. Uh, I found this very cool widget, which basically you can add to your website if you have one. Basically, it allows you to add your social media content to your website in such a very cool way. And I want to share that with you so you can actually see how it looks. Let me just go to my website. So in case you ever want to do something similar, it does that. And guess what? It's not popping. Let me bring up this one. Give me 1 second. I'm just popping this up. Oh, there you go. All right. So let's see if you can see this. So if you go to my website now, what I added was this widgets below my main content, which basically you have your YouTube media channel, your Twitter, and your Instagram. I think it's very cool. I was looking for something like this to add to my website, but I did see some which I didn't like, but this one looks very cool. So I just wanted to share that with you in case you have a website and you want to add it and you want to add social media. The application is called Elf Site, Elf ELF site.com. So you may want to check it out. All right, so let's do some game engine development. All right, how can I start? Basically, this is the problem that I've been trying to figure out and see how we can actually do this. So let me bring up Xcode, all right, and let me bring out Blender also so you can see what's going on. So right now, what I have is basically a 3D model and a plane here, and what I want to implement, I want to make the 3D character be able to go uphill and downhill. So basically, be able, for any character to detect the slope and just change direction, going up or going down, depending on the direction of the slope. So I thought about this, right? I was thinking, well, how can I do this? How can we make this work? And what I figure is that we need to use some kind of array caster, right? Array cast, which basically will shoot downwards from the point of the character and detect if it hits the plane, right? And furthermore, we need to know the location where the ray hit the plane, and from that detect the slope at that particular location, right? And that seems complicated, but it is not, right? Because as you know, a mesh is composed of bunch of uh, uh, triangles, right? Such as what I'm going to show you right here. So right here, in Blender, I'm basically going into edit mode, and I'm showing the whole plane into the individual triangles, right? So one thing that how we can make this work is wherever the position of the character is at that moment, or what we can do is shoot a ray from the center of the character downwards, right? um, and then detect if the ray hit the particular triangle. Now from that triangle, guess what we can have? We can get that normal, like the normal vector of that particular triangle, also known as the face in 3D modeling, right? So we can determine the normal of that face. And once we have that normal and we have a direction of the character, we can do some mathematics to change the direction of the character. All right. So what I did the whole week, basically, I did two things. I modified the script that I wrote, which extracts all of the data of a 3D model um, to the engine. And what I did is that I added, I also extracted the edges and the faces that make up this whole mesh. Previously, I was only extracting the vertices. Let me just point that out, like the particular vertices, right? That's all what I was, exporting. Well, if I want to do something what I just explained, I needed more than that. I needed the face, I needed the edges, I needed the normal. So that's, I went ahead and extracted not only the edges of a triangle, but I also extracted the whole face of every single triangle, right? And now I have that particular data that I load into a buffer of an object, and hopefully I can do something with that. Haven't figured out yet exactly. The next thing that I did is I implemented a array class, and the array class were Xcode. And the array class basically, if I go to my mathematics section, all right, so let me go over the array class so you can see it. Array has an origin, position, it has a direction. So this is what I have here, implement the declaration of these pointers and vectors. I have a constructor, and what I currently have in this array class is I have two functions, two methods. One of them that intersects a plane, and the other one that intersects a triangle. And I implemented them here. And basically, that's all what I have. And hopefully that's enough mathematics that I need, but I'm thinking I'm gonna need a lot more. Just so you know, if you're wondering how did I actually was able to detect if a ray intersects a triangle, actually that's very simple. I'm not going to go into the whole mathematics, but I'm just going to show you the whole logic that you need to follow. And let me bring up my notebook here. All right, hoping this will, okay, cool. So the first thing that I do is, let's say I have a plane here, okay, and I have a ray. Um, when I detect if the ray hit the plane, I make sure to get the intersection point. All right, and that's the key, right? So now, if I'm trying to detect if a particular ray hits, so let's say this is the ray, right? My ray. If it hits a triangle, what I do first is um, I know that the face of a triangle makes up a plane, right? So let me just do this. From the face of the triangle, I know that I have my D and I know I have a normal, right? So this triangle here, in reality, is making up a plane, right? A huge plane. So the first thing that I do is I detect if the ray hits the plane, right? And I get the intersection point. That's the key. Now, once I have the intersection point, then I check if that point is within the barycentric points of the triangle. If it is, then it means that the ray does intersect the triangle. All right, and that's how I'm actually detecting everything. Okay, so let me go back to here. Now let me go back here. So that's what I did. I basically implemented this class for a triangle, which is okay now. And what I'm doing now is actually, well, I have data for my faces, for the mesh faces, for the edges. Now I have array. Well, what is next? Well, next I need to come up with a class that is responsible that of detecting if a ray intersects all of the faces that makes up a triangle. Okay, and from that determine the slope of the triangle. And so what I worked on also was on implementing array class. Now I do not know if this will work, but from what I can tell, it may actually work. So in the array class, in the raycast class, what I have a method, a function called hit, which basically takes in as a parameter the array, the 3D model, and it returns the triangle that the array actually intercepted with. So basically, what I do here. Let me just go over the code. So the first thing that I do is I get a hold of all of the faces making up the mesh, right? And all of the faces, as I told you, were exported from the script. So I get a hold of all of the faces. And then what I do something that I'm not very proud of, but I'm taking baby steps. What I do is I loop over every single face in that mesh, and one by one I test if the ray intersected a particular triangle, right? And if it did, I want it to say yes, it did hit, and I'm given also, and I'm returning the face, the triangle that was intercepted with. Now here, what I also do is I make sure, since a mesh, right, could have like the ray could go through the first face and come out through the other. What I have here, which is very not good, and I admit that it's not good, is actually, it can actually return the incorrect face, right? It can start out with this one, but then since it's a for loop, it can also end up detecting the other face on the other end, and it's gonna say, oh, this is the face that you're intercepting, but no, that's not it. Now, if you notice here, I actually have all of these faces in a vector container. That's not good when it comes to efficiency. It's okay for now because I'm just testing it out, but when you have a mesh that is composed of 1,000 faces or 2,000 or even more, doing a for loop with a vector container is not ideal. You're gonna waste a lot of time just going through every triangle. All right, so now what I have here, let me go to my earth. Okay, so let's do a simple test here now. Okay, so what I have here, I'm going to render this so you could actually see it. So I'm here, I create an instance of the astronaut, and here I create an instance of the plane. Let me actually render this so you could see it. Let me turn on my... Give me 1 second. I'm waiting for it to turn on for my controller. What are here they are. All right, so I'm gonna render this. I'm gonna go to Mac. All right, so I'm gonna move the character with my controller, and you can see that when I rotate it, it's obviously it doesn't go up. What we want is for the character to go up once it detects that particular slope. All right, so but let's do a little test here. What we're gonna do here is that we are going to test. We're gonna shoot a ray from the location of the character downwards, and we are going to display the normal vector for each triangle in that location. All right, so let's do that. Okay. And unfortunately my headsets don't work. All right, so let me go here, and what I'm gonna do is, what I want to do is that when I press a button on the controller, I want to hit array, and I want to get the particular norm of that particular a triangle. So let me include here the ray class, and here for the ray cast.h. Alright, so under A, what I want to do is create a array, and let's first give it the origin, E for the engine, E for the point, 3n, origin is gonna be, and then let's give it a direction of a vector, 3n, call it ray direction. And we wanted to go, no, actually what we want is we want to get the position of the character at that point. um, that's my origin, all right. The direction is going to go downwards, but my origin actually is going to be um, my or the position of the character at in that instance. Get absolute position. All right. And believe it or not, I tend to forget the API that I wrote. So let me go to the website, which is very handy. And if you go here under Learn and go to API, that shows the actual API. So what I have here, I need to go to game objects. I believe it should be here. No, it's gonna be here. Hold on. Get absolute position. Oh yeah, I was right. There you go. That's the what I wanted. The absolute position. Now it's giving me an error because with this actually returns a vector. As you actually saw here, it returns a vector. What I need to convert that to a point because origin is actually a point. So all you need to do is to say 2 point, and that will convert it to the point. All right, so we have that. Now we can create the array. For the array, and let's call it array. And for this one, I haven't done the documentation yet for this, so let me actually see the parameters. So it's origin and the direction. All right, so origin and array direction. All right, so now we have the array. Now what else do I need to do? Now I need to do the raycast class. So you for the engine, you for the raycast, and let's call it raycast, just like that. How do we do that? So we create a raycast just like that. Then we do a head ray model triangle. All right, so raycast. Raycast that head. And this one is gonna be the ray, then the I need to get a pointer to the plane, right? Because what I want from Blender, I want to get so basically the ray is gonna go from the position of the astronaut all the way going down, and it's going to the raycast is going to go through every single plane in this mesh. And return then the one that it hits. So what I need the pointer to that plane. All right, so I'm gonna get it in a second, and then from here I'm gonna get the let's call it face hit, and that's a triangle. So I need to provide a triangle face hit. All right. Alright, okay, so let me get the pointer to the plane, and I just need the name of this guy. So get pointer to plane. So I need to add a here, but I need to add a here. And this is gonna be for the game object that h. And let's call it p plane. Alright, so p plane is gonna be dynamic. I'm gonna cast this for the game object. Now p earth search. We're gonna search the thing graph that we added, and the name is plane. There you go. So now I should have the pointer to the plane here. Okay, so that's the p plane that I was referring to. All right, so you know what? Just for the heck of it, we need to be safe here, right? If p plane is not a no pointer, because what if I don't find that guy? Raycast. Okay, so raycast, it returns a bool. Alright, so if there's a bool on that, so if, oh god, let me change this. Okay, so since raycast returns a bool variable, we need to put it into an if, right, just to make sure that we did hit something. Now freeze hit. Okay, now we have my triangle, right? Let me see if this fails. Just want to double check. So I bought these earphones, but unfortunately they're not working for some reason. They lose connection, which sucks because I wanted to listen to music as I was coding. I think I have to return them today then, because I actually got them last night. Alright, let me get some coffee. Okay, so we're good. Everything succeeded. Okay, so now we have the ray, it hit. We need to get getting the face. What we want from that triangle, we want is the normal of the triangle, right? So let's create a vector, because a normal is a vector. And let's call it face normal, and that would be the face hit. You know what, I'm sorry, I need to be more descriptive with my naming, or else I'm gonna go nuts. Triangle hit, triangle hit. Let's call this triangle normal, and then triangle hit. So since it's a triangle, you can actually get the normal for the triangle. That should tells me by the way, if you ever developing with the Untold engine, use this documentation. It's quite good. Well, I'm still working on it, right? But I like it. So the method that we need is get triangle normal, and that will return a normal vector of the triangle. get triangle normal. All right, so that would be that. So now what I just want to display that. I want to actually see it. Normal show. The show method actually uh, outputs in here in this window any the value of the vector. All right. So something's wrong. What's going on, boys? Boom, boom. Okay. What's the problem? Yeah, everything's good. Okay, so we have that. Okay, let's actually play this. I'm gonna move this to the other screen so you can actually see the results here. But you know what? Before I do that, actually, let me just run it. This is building, so if I click A, okay, I saw something here. I need to normalize this. The vector normal. The triangle normal needs to normalize. All right, cool. All right, so I'm gonna move it over here because it actually seems to be ready. All right, okay. So this is so we can just see what's going on. Okay, so right now I want to hit the key A, the button A on my controller. And we should see something. Okay, there you go. So it's detecting that the normal that is currently being hit is 1 going up, which is what we expect. Now we may run, how about the normal there? Let's see, I'm gonna hit it. And that's showing that it's going negative direction, which is correct because it's going that way, right? And then the next one is up, and it's 0 because I haven't moved up from my z-axis yet. So now let me keep on going. Now, I don't think I'm gonna get any value here because hold on, let me actually do this. I'm afraid that at that point it's not gonna get anything because the position of this guy, of the astronaut, is actually gonna be right below. So I'm gonna move this up so that way we can actually get something. Let me export this resources, base asset. All right, so now let me go back to this window, and now let's run it again. Oh my gosh, man. All right, so now let me go here. Now if I'm over here, I should get the slope to be a little bit steeper. 0. All right. Now here on this slope, I believe it should be right. That's about right. Seems right. Okay, let me go back here. Now here should be something. Here should be some. That's right, because I'm almost flat. That's correct. Now if I move, by the way, what I'm looking at is at the numbers here. I hope you can actually see those numbers. You might not be able to see them, so let me move my screen here a little bit. All right, so I'm gonna hit it here. It's 1. Now let me go over here. -1. So let me check here. So here the face is pointing that way, so it should be positive 3, which is positive x, 1 and 0. Okay, so I think we're good here. We are actually detecting the normal of the triangle that is being hit by the ray, which is what we were going after. All right, so let me go back here. Okay, so now that we have that, what should we do now? What should we do? Okay, let's do some brainstorming here. Okay, so let's say that I have my slope here, right? And then I have my character here, and I'm just gonna use a black here, just for the heck of it. In this location, my normal is going up, right? So it's going up. That's my normal of the plane. The direction of my character here, let's say, is moving that way, right? That's my direction of the character. All right. So the other thing that we notice here is that if we take into account that this is actually a 3D object, right? That direction, the angle between the plane that is being hit and the direction vector of my character at this point is actually 0 degrees, right? That's that. But now if my character happens to be in this position right here, right, my vector is now pointing this way, my normal vector is pointing that way, my direction is still pointing that way, right? So what I get from here, I get my normal vector, I get that direction of the character, and from here what I get is actually an axis of rotation, right? If we do, for example, D cross N, that will give me this axis right here. Let's call it I don't know, what can we call it? W. It will give me W. That's my axis of rotation. But now I need let me bring this up a little bit here. So it's a lot clearer to see. But now the problem is this, that this is my D, this is the normal, the like the ramp, the slope. Now if you take a note here, if you look at this carefully, you notice that the angle between the direction of the character and the plane are not parallel, right? And what I need to make sure that this this direction is parallel to that plane, right? So it's gonna be something like this. So I have my plane here, and I have my direction here, and I need to bring this D up. So this could be my angle of rotation. So basically I have an axis of rotation which is given by these two vectors, right? D cross N. And I also can get how much I have to rotate by determining the angle between my plane, between my triangle that I'm hitting on, and my current direction of the character. How about that? That could actually fix it. That will make my character rotate however many angles it needs to rotate up. And what it will do in that instance, I can use a slurp interpolation, and then at that point the direction of the character will be parallel to the plane, right? An angle of 0. That is what we can actually do. I think we got it. I think this may work. Okay, where do we do this though? I need to simplify all of this. The problem that I have here is that I'm having so much code. This, by the way, okay. By the way, the part of the engine, what is the engine here is actually this folder, Untold Engine 4D. The folder for game, that's actually just a demo, so you can actually play around with. But what I need to do is I need to check my direction for that. Where do I check that though? I don't want to do that every time I move the joystick. I want to constantly be doing that, making sure that my angle is 0. So, well, why don't we do it in my astronaut class in the update? That will make sure that I'm always being 0 no matter where I'm at. Yeah, why don't we do that? Just for the heck of it, just to see if it works. Alright, let's do that. I want to get all of this, what I have here, what I did here, and I'm just going to remove that, and I'm going to put it under my here. I'm sorry, I'm actually thinking because I don't want it to affect what I have right now. So it's walking my fourth direction? So my fourth direction is that. Okay, I got an idea. Let's forget about that for 1 second. I'm gonna forget about all of these things right here. Because I don't want it to affect what I want to do. I don't want it to make it more complicated. I want to simplify this as much as I can. All right, so let me comment this out, and let me comment this out also, so that way everything looks everything is nicer to do. Okay, now all what I'm going to do here is that when I move my joystick, I'm just going to translate my character. Translate by my joystick direction. But this, I'm gonna actually reduce this quite a lot by 0.1. All right, let me see if that works. So I'm just simplifying things right now because I don't want to make it too complicated. I want to see if this works. And right now the code that I have with all that walking and the rotation and everything, I feel it's just making things more complicated, which I don't want to do that right now. Translate by. Alright, it's building. Let's see how this goes. Alright. Good. That's not what I want right now. Okay? Nothing fancy yet. However, what I do want, I want to rotate this character. Then that's the other problem that I'm gonna face, huh? All right, got it. Rotate astronaut. Rotate by, and I want to rotate this by my x-axis. It's gonna be 90 degrees. I'm sorry, rotated by my y-axis. And I forgot to show you what I did, but basically I just wrote a simple method. No, I didn't write the method. I just called the method to rotate the character by 90 degrees about my y-axis. So now I should just show up on the other way. There you go. So now when I make it walk, there you go. That's what I want. So just for this, you know, we're gonna show it that it's gonna go up and down, boom, boom, boom. And let me bring it down from Blender so that way we can actually see the whole thing. Boom, boom, there you go. So I'm gonna export this to resources, space asset. Okay, so now we should be good now. And I'm telling you, I forget to show you what I did. Basically what I did right now on Blender, you know, if you recall, the other character was up here. I basically just brought him down to the ground level with so that is on the same level with the plane. That's basically what I did. All right. So, let's see. Now that we have that, now what we can do is when we are moving the character here, that's when we do our ray cast. That is when we actually change the direction, right? And I erased everything that I wrote. God damn it. Well, guess what? We have an undo. That one. And this is the one that I wanted. Alright. Okay, so now let me just remove these guys right here, because I'm not gonna need this. Alright, and let me get this guy here, and I want to do the same. The same, I tell you, the same. Alright. So now let me paste this. Okay, now I have the ray here. My astronaut, I get my position, I get my direction. For the ray, should I have the ray direction? Oh, well, the ray needs to change. That needs to change. Depending on my current, see, my ray direction that I have right now cannot always be pointing downwards, right? Because at the moment that the character is in this particular location, the character will rotate, right? So I need to somehow make sure that the vector also changes, so it's pointing that way with the, oh no, not really. I think we should be okay for now. For now we should be okay. We're just testing this out to see if it will work. So let's just keep it like that. So we have the ray direction, we have the ray, now we have the ray head, boom, normalize. Okay, so now this is the normal I was talking about. So what we need now to do is we need to do some linear algebra. First thing first, we need to get my axis of rotation. Get axis of rotation by doing a cross between the triangle normal and the character current direction, right? Now that will give us my axis of rotation. And once I have that, I need to get angle between the plane, right? The plane of my triangle. Between plane of triangle, which means I need to get those. Alright. And the current direction of character. Alright, so let's do the first one then. Well, okay, so once we have that, what do we do? After that, we simply do a slurp, right? We do an interpolation. Do an interpolation to the no. What we're gonna do from here is that once we have the axis of rotation and the angle, we're gonna create a quaternion for the new orientation, right? Once we have the new orientation, we are going to do an interpolation between the old orientation and the new one orientation, so that way our characters nicely flips. Okay, now do an interpolation between old previous orientation and new orientation, and then rotate to new orientation. Right, and that's what we're gonna do. Rotate by new orientation, by new interpolation. All right. All right, so let's get the axis of rotation. You know what? After this switch, I'm gonna go to the store and actually get me a good headset, because I wanted to listen to music, and I cannot do it right now because if I play from my computer audio, it's gonna sound wacky. So I didn't want to give you a bad experience during my Twitch. All right, so now let's get to work. Let's get the axis of rotation. For the vector 3n, so axis of rotation is equals to, and if you recall this, my axis of rotation is going to be between my direction and n. So I'm going to do a cross product that way, right? So that way I can get this guy. Okay, and if that's not the case, then we just flip it, right? And that's all we do. So nothing to worry about. All right, so it's going to be my direction. And we need to get my character direction. So let's do it here. U for the engine. U for the vector 3n. So let's call it astronaut direction. And this is gonna be P astronaut get view. Is it get view direction or get in view direction? Let me look it up here. Let me go here. Model. Where are you? Is it view or get view in direction? Method which returns a 3D vector representing the current view direction of the 3D model. Get view in direction. All right. Get view in direction. Okay. So astronaut direction that cross triangle normal. And you know what? This guy should be normalized, by the way. I just want the actual axis. I'm sorry guys, what I'm gonna do here is I'm actually going to default to my normal. Is this the normal? Hopefully it's not too small for you guys, but it's kind of getting on my nerves now. This looks weird though. Oh yeah, that's it. Okay, so this is ray direction, my ray. I have my direction here. Actually, I think this is gonna be better for you guys, so just let me just bring it up again. Sorry guys. You like that? If you prefer the other way, let me know, so that way I can actually go back. I think this is good though, so that way you can actually see things. But I don't like the fact that it starts to break the line. Okay, but okay, let's just go for it. Now, so we have my axis of rotation there. Now I need to get that angle between my plane and the triangle. Now, does my plane actually U for the plane? I need to make sure, double check that I can get the angle between. I compute the angle between planes. God damn it. I actually need to between planes. How about triangle? U for the triangle. We need to get triangle normal, distance to plane. Well, from my triangle, you know, if we think about this, right now we want to get the angle between a line and a plane, right? Which is where my triangle is at. Right? How can we do that? A plane and a line. Well, at one point these guys should intersect my plane. A particular point, I should intersect it, and somehow I should get that. How if I can get so let me have here a plane and here my triangle. Hey, hold on, hold up. So my character, right, has a point. It has a location from my origin, right? From my origin here, right? Now let's call this P, right? Now I also have this particular vector right here, which could be called let's call this I don't know what the heck, R, right? And what I have here, I actually have a plane, right? From my point. So a plane is composed of what? If you think of a plane, right? We have a plane here, right? It's composed of a normal vector, and it's composed to a particular distance, right? That's your plane right here. Well, I have the same thing here. I have my character, which is up to a position, a particular distance from my plane, and I have what could be considered my normal to that plane, right? And that could work. So now all what I need to do is get the angle between those two planes. So in the case where we have a plane flat and my character just here, this is going to give me two planes that are diagonal, perpendicular to each other, right? Because boom, 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 they're perpendicular to each other. Well, $90. And what happens if my plane is slanted and the plane composing this guy, my character? I'm sorry for my illustration, guys. I know I'm really bad, but this is actually how I work. So let's see, right? Let me just clear this up. So let's say I have my character, which is a box for now, and I have this, right? Okay. Currently, what I need to get the angle between this vector and a plane, all right? Well, the only way that I can think of is that this my x, y, and z, right? I can create a plane from my current location of the character, right, and the particular direction that it is taken on, right? So that creates a plane, and whenever the character is on a flat surface, the angle between the plane created by the character, which is something like this, and the plane that I'm hitting on would be 90 degrees, right? And if whenever my character is in this particular location, right, now my plane made up by the character is that, and the other plane is going to be a little bit slanted now, right? So now I have this particular angle, okay? And my goal is to make sure that the difference is always 90, so that way I would rotate the characters to 90 degrees always. So what would happen if I rotate it? It's gonna be something like this now. So let's say my character is on this particular slope now, and I rotate it. So now I would have one plane, which is the plane that is of composing my floor in this case, and then I have the plane making up the character, and that will create two planes made up from 90 degrees. That could be it, right? That could actually work. All right. All right. Oh my God, there's so much work because I want to make things a lot simpler. Right. Okay, so here got an angle between plane of triangle and the current direction of character. Well, from my triangle, can I get uh my plane for my triangle? Well, you kind of can do it, right? I can get a point distance and I can get my distance to plane, but I don't have a plane. Okay, for my triangle, what I can get my normal, which is what I want, and I can get my location of my triangle right now, right? Which is get centroid, which method which determines the point of the triangle of the location. Yeah, that should do it. Okay, so first of all, man, I cannot work. Let me just change this, guys. I'm so sorry. I'm just gonna change it to this. But why is that? Oh, interesting. 13. Let's make it 14. Okay, that looks better. All right, so raycast. Get angle between plane. Well, I cannot do that yet. So what I need to do is I need to get the distance. Let me get the centroid of my triangle. Get centroid of the triangle. Okay. So it's gonna be for the engine, U for the vector 3n, centroid, and then triangle head, and get centroid. Yeah, get centroid. That should give me that. Now I want to see, because since I want to create a plane, what I need are these two. I need a point. Hold on. Get out of here. Oh, hold on. I have a plane here. I just need the points of my triangle, and that should give me my plane. So I should be good. I should be fine with that. Okay, cool. I don't need to do no intersect segment, intersect plane. Compute angle between planes. Alright, so that's what I need. All what I need are my points. Right. Point A, B, and C, and that should give me a plane, which is what I want. Alright, so we're just gonna create a plane. Alright, so create a plane from my triangle, which makes sense. Alright, U for the engine, U for the plane. Let's call this Papa hit plane, right? And we are going to make it from my triangle head. See, this is what I hate. I hate when I don't name things properly. It drives me insane. Hit triangle. By the way, I'm actually doing this stream today because guess what? My game got canceled today. Something with spring break. So hit triangle. So I should say point A if I recall. Man, I'm so. If you ever decide to do your own API, your own engine, your own application, man, one of the things you need to focus on is actually uh, uh, is your documentation. My gosh, you have number one, you have no idea how much work that will take. Number two, it's necessary. I mean, there's no way around it. You cannot just put it aside and think that you will never. You're not gonna use it ever. That is something. If it must be taken care of with, you know, the same way that how you put a lot of effort in developing your API, your engine, your application, you need to put a lot of effort in writing your own application, your own documentation, because you are going to need it, especially if your application is quite huge and big. You are going to forget that your own API. Believe me, all right? Because I wrote this whole engine by myself, and I still need to go to my documentation and read my own API. I know what it can do, so I know where to look at, what functions to look for. But sometimes the whole naming convention over the times, if you're gonna forget it, I mean, there are classes here, functions, methods that I wrote 5 years ago, and I'm like, dude, there's no way I can remember that. I mean, in 10 years, which I hope to keep working on the engine, I know I'm not going to remember every single API function that I wrote. So, all right, so we have created a plane here from my triangle. Okay, now we need to create now a plane from my character. All right, so create a plane from the position and direction of the P astronaut. Okay, now number one. All right, let me see if there is a nice way for me to create a plane. Alright, so we either get the points, which we don't have those points. The other one is to get a distance and a 3D point in space. Well, I can do it from here, right? That normal would actually be my direction, and my U point we could be actually be my position in space. That may actually work. I wonder if I could actually flip that normal, that direction, flip it by 90. I wonder. Well, let's just go that way. Alright, so U for the engine, U for the plane. By the way, what I'm doing here, I'm just testing what I wrote for the engine. And I know this is making things more complicated, and I'm aware of that. I want to simplify all of this. But before I move on, I need to make sure that my thought process is actually correct and I'm not doing something dumb, stupid. So, that's why I'm doing this right now. Let's call it P astronaut plane. All right. And we are going to do that from my direction and my position of the astronaut, which is this one. Alright, so and origin. And again, I hate when I do this. Ray origin. Oh, great. Position. That's what I want. Astronaut. Alright, so now that gives me a plane. Alright. Now let's get the angle between those two planes, and you know, we're gonna test this. We're gonna test the heck out of this, guys. Let's get the angle. Float angle between planes. It's gonna be my hit plane, that angle, and P astronaut plane. All right, now check this out. I'm going to output this so we can actually see it. Now when the character is in locations such as what we have here, right, with our plane should be, the angle between planes should be 0. You know what, I should have used a Blender, man, to show you what I'm gonna do. That's, oh man, next time I'm gonna keep that in mind. So you know, I'm gonna do a plane here, and let me rotate this guy y90. All right, so this is a perfect scenario, man. Next time I'm gonna use this. Why didn't I thought about that? All right, so right now the angle between the two planes that we created should be 90 degrees, right? When we test it, should be 90, right? When we start moving along with the character, right, the angle between this particular angle and the plane that is created by a particular triangle that I'm hitting should not be 90, should be different now, right? Should be I don't know, 70 or 85 or something, right? And as I keep going, come on guys, as I keep going, it should be different. Right? And once I get over here, it should be 90 again. All right. Let's do that. Let's see. That's what I've been, what I was trying to talk to you guys, man. I should have used Blender to actually explain that better. I never thought about doing that, but next time I'll do that. All right. Let's go to this and let's fix this. All right, let me bring this over here so you can actually see. And guess what? I forgot to turn on my controller, so let me turn it on, or else it's not going to pick it up. All right, Let's see if this works. Let's see if this actually works. All right, you're here. You're here. 90. There you go. It is showing us 90, but why are you not moving? You're not moving. You're not moving, boy. You're not moving. Let me fix this. Oh, I'm not asking it to move, right? Oh, you know what happened? What happened is that when we uh, all right, let me do this really quick here, so that way we can actually make a move. Boom. I'm actually going to make a move here once everything is set. No, make a move here, 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 here. I'm going to remove, scale it down, and P astronaut translate by, and I'm just going to do that. Okay, that should do it. All right. Good thing we're getting 90 degrees, which is what we were expecting. Okay, but now as we keep walking towards the right, our angle should decrease and then should go back to 90 if everything looks correct to me. All right, so 90, 90, 90. Let's do this. Let's do this. 101. It went up. Okay. 101. 112. Okay. You know what's happening here again. So something that you need to keep in mind here is that my character is here, so we should move it here so that way we get the correct readings here. Boom, that one. Now let me go back here. Now I'm getting 101. My actually let's see this. Let's test this. Now I should be getting 112. Now I'm getting 90. So everything looks good. But the problem is now that I would think that my angle should go down. So that's 90. That's good. Oh, look at that. It's flipped. Everything is flipped. Alright. Welcome to the world of game engine development, guys. These are so many things you need to take into account. Alright. Let me go back here then. Number one. If we look what's happening here, is that as pretend that this plane is actually the character moving, because that's the plane that we are actually creating. Man, you know what? I wish we could just rotate that plane, and we can rotate the normal, but I don't know what would happen if we do that. How will everything affect it? A plane, and we rotate that by 90 degrees. That would be awesome, but let's see. Okay, so for some reason this angle are bigger than 90, and is it because I'm getting the unless if my vector, unless if my the normal is pointing that way. You see, if my plane, the normal of the plane is pointing this way, right? So then the angle is going to be higher than 90 as is shown here, right? Which is correct, and that's why when I come over here and the characters move this way, the angle starts to decrease. All right. What we really want is the, let me just move over here. What we want is that direction. All right, then let's test this then. You know what? We need to make sure which we need to double check my astronaut direction. Where are you going? Is it pointing that way or this way? All right, I'm going to comment that out, and I'm going to get my astronaut direction, get view in direction. My get view in direction on. Okay, astronaut direction that show. Okay. Oh, you know what, guys? No, that's actually correct. My okay, I got it. I remember why. Okay, so your triangles, right? They should be set up in counterclockwise, and I think that could be the problem. All right, that could be it. Because my direction should not be the problem. I think it's how I'm creating that triangle that is the problem. All right, so let's do that again then. All right. Man, I forgot to comment the angle section. God damn it. All right. Let's do this, boys. Oh, man. Boom, 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 boom. And it's coming. All right, so 90, 90, 90. Boom, there you go. It was the triangles that I was forming. I was assembling them clockwise, but when you are developing a game engine, you need to keep in mind and keep this all throughout your code, whether your triangles are going to follow a clockwise pattern or counterclockwise pattern. And as you saw right now, that will actually create issues if you don't keep a uniform connection between the points whenever you are working with meshes, or in this case with the faces that makes up the mesh of a character. Okay, so we have the angle, and that is correct. And just to double check. All right, so now our next step is, right, we have the angle. All right, now it's gonna get fun. We have the angle between that. I have my orientation axis. Now I need to know by how many. Oh, got it. It's simple, guys. It's simple. All right. So we are going to create. I need this to always come up to 90, right? Whenever I go above 90, I need to decrease it. Alright, alright. Okay, cool. Alright, so actually I'm gonna look over something here that I did the other day, because it actually shows how we can use this interpolation. Now my angle. Okay, let's test this out, guys. Let's just go for it. U for the engine, U for the quaternion. Let's call this Q, and now we're going to create it by giving an angle. My angle between planes, and my axis again would be good idea if we can go a quaternion. Now quaternions, we can create them using my angle, which is this guy, and a vector, which is my rotation axis. Alright, and axis of rotation. I got this. Alright, so if angle God damn it. What I want is basically it's gonna be 90 minus that, right? Now if my angle between planes, hold on, okay, create that. Give me 1 second. Come on. Let's call this new orientation. Okay, and now we are going to do a slurp, right? Basically we are going to use the method slurp to get the new orientation. Alright, so U for the engine, U for the quaternion, let's call this orientation slurp equals, that's gonna be that's what I forget always, my model orientation. Okay, how I got in my model orientation, I need to get my current orientation of the character, right? Let me get it here. U for the engine, U for the quaternion, astronaut orientation, and this could be astronaut, get I have it right here too. I don't need to go over there. And you can use absolute space. This guy right here. All right. So now that's going to give me my current astronaut current orientation. Okay. Now we can use that over here. Then we do a slurp to my new orientation and 1.0. Let's go this new okay, well that's over here, should be okay. And then we just rotate it by the new orientation slurp. So P astronaut rotate by and then we rotate it by this guy. All right, now let's see what would that do, because I have no idea what that is going to happen, which is something very cool about game engine development. You many times, 99% of the time, you have no idea what something that you implement is going to do. And this is what I actually love about game engine development. It's all discovery process. It's all experimentation. It's all about trying to see how you can implement a feature. And many times it takes weeks of trials and errors, and finally you realize, oh, this is how it works. This is how you need to do it. And this is what we're doing right now. It's all, just going through the whole phase of being lost, and finally, after a couple of days or so, finding the light from, in the tunnel. So, rotate that. Okay, so now what's going to happen is that in this instance, when I'm over here, the angle should be 90 degrees. So 90 minus, here I'm actually subtracting a 90 minus this, which should be 0, right? So which means that the character should not, the new orientation should be actually 0, so there should be no movement. However, when I get to this angle, to this section right here, to this part of the plane right here, the angle is now no longer going to be 0, right? It's going to be 70, right? So 90 minus 70 is 12 something, 20. I'm sorry, 90 minus 70, 12. 90, it's like about 20 degrees. So then my character should rotate. Okay, now to be honest with you, I do not know which way it's going to rotate, either up or down. Either it's going to rotate that way or that way. We're going to figure it out. Right, it's all learning process right now, so nothing to worry about. Okay, so let's do the test right now. Okay, let's see what this is going to do. Oh boy. So 0, 0. Oh my gosh, rotate. Yes! It rotated. Look at that, boys. Hell yes. Oh my gosh, I'm not even showing to you. I'm not showing you what happened. Let me show you guys. Watch. So now I'm here, and now when I get to that point, I actually rotate it. Which looks okay, and now it comes back, and now the other one, it flows the whole path right here. All right, it seems to work. We can fix this though. We can still fix this. All right, so let me actually bring. That actually worked. All right. Let me get rid of this plane because I don't want to export this plane right here. Oh, that's so All right, I want to put it right there. All right. I was actually concerned if that was going to work or not. Okay, now let me go Mac. Show my Mac screen. Okay. All right, so we're here. So it's so cool. Yes, I know. But it shows the fact that it's when it detects that it works, right? 50%, right? Everything seems to be okay. We can actually do better. All right. Let me see what else could be done actually. Let me bring it up again. Just for the heck of it, because I do want to see something. Okay. Now, let me hide this and let me I'm gonna play this over here. Alright, so we can actually improve this, you know that you know how if we actually put that in the update method, so that way it's constantly what's gonna happen if we since we are not taking into account the other one, so alright, this is cool. At least we are getting somewhere. What if we put that in the update method? I wonder how would that affect it. Well, for that to work, we're gonna need to get this guy right here, the plane. But let's do that. You know, let's actually do that and see if we can actually, if that will actually work. What is this? This is my original, which is, I'm just gonna comment this out just for the heck of it. Create this and boom, that's all what I was doing here. What I'm gonna do, I'm going to move that to this location into my update method, and in my update method I'm really not doing anything for now because I'm just testing things out, so I'm not, you know, doing anything. All right, one thing that we do need is my plane, which I do not have, but let me just put it there, array.h, and include view for the raycast.h. And that will fix those issues. Get absolute, get this. I'm basically just removing all of the pointers that I showed up before. Okay, now plane, that's the guy. Okay, I'm gonna do this. Oh, should be there. Should be worry. All right. Oh, what I'm gonna do here, I'm going to do declare for the game a pointer to game object, and I'm gonna call this p plane. All right. So what I'm gonna do, Oh boy, actually no, that's not even good because. Alright, I'm gonna do something so bad that you should never do in C++. Ever. Ever. I'm serious. You should never do this. But I'm just gonna do it. Just for the heck of it. Alright. P plane. No, sorry. I need to get my parent first. Parent. So get parent. Alright. So now I'm gonna get the parent of my astronaut, right? Parent of astronaut. And what this is going to do is actually it's going to return a pointer to Earth, right? And recall that Earth has something that I need from it. It has from that I can actually search my child. All right, so now you for the what you don't like this, the heck is your problem, boy. You for the game object, I'm gonna call it p plane, and I'm gonna do this parent. Actually should work, seriously. Oh my gosh, I'm actually surprised that I'm actually glad that actually worked, because I was concerned of how we were gonna do this, but now we are on a good track to make this actually work all throughout. All right. Dun 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 dun. Okay. One thing that I wanted to tell you about, you should never do in C++ ever. I mean, never use a dynamic cast, okay, throughout your game. This method right here, update method, gets constantly called. All right. And within that method, I'm doing something bad, which is doing the dynamic cast. Don't ever do that, ever. All right, move that somewhere else, that so you can only, so that you would only call it once in a while. All right, but I'm just doing it here just because I want to test if this will also work. It should. I don't think it will be a problem, but just for the heck of it. But you've been warned. All right, so boom. Oh my god, look at that. Yes, all right, guys. We actually got somewhere. All right. Okay, now I'm gonna stop this. Okay, this is a good place to stop. I'm gonna go get something to eat right now, and I do not know. I may actually do another stream right after I eat. Um, I may also have to go to the store, but if I actually decide to do that one this evening, I will let you guys know. So go, if I were you, I will follow me. Follow me on my Twitter account, so that way I give you an update if I'm gonna be live. Tomorrow I'll definitely be live again. I'm gonna be working on this. I'm actually happy that we're going in the right way. As you can tell, there's a lot more to work on, more things to do. My whole hope is that that the engine will automatically be able to help a 3D character go up a slope and down a slope, so that way that you don't have to do all the leg work, so that you can just focus on doing your gameplay and not dealing with the technical not oh, and you don't have to deal with those little details that sometimes makes game development a little bit too much work. Um, all right, guys. So thank you so much for joining. I will let you know if I will be streaming this evening, and definitely tomorrow. So do join me tomorrow. All right, guys. Thank you so much. Have a good day.